Let's move to the next question. In this question, by reduction of 1 rupee per kg in the price of sugar, Mohan can buy 1 kg sugar more for 56 rupees. We have to find out original price of sugar per kg. Let's work out the problem. To solve these kinds of problems, we should understand the meaning of the question carefully and then frame algebraic. Then we have to frame quadratic equations. Let us assume price of sugar per kg be x rupees and quantity of sugar be y kg. In this problem, we have given the total cost, which is product of x and y, and it is equal to 56 rupees. So we have xy is equal to 56. According to this problem, by reducing 1 rupee in the price of sugar, Mohan buy 1 more kg of sugar for the same price, that is 56 rupees. Let's frame the algebraic equation. Then we have new price of sugar is x minus 1 rupees. And then Mohan buy 1 more kg of sugar, then the new quantity of sugar is y plus 1 kg. Now the total cost for y plus 1 kg is x minus 1 times y plus 1, and it is given to the original cost, that is xy. Thus we frame this algebraic equation according to the given condition. Let's solve this for x. It is because we have to find out original price of sugar. By multiplying these two expressions on left hand side, we get xy plus x, and let us multiply negative 1 to y plus 1. Then we have negative y and negative 1, which is equal to product of x and y. Left hand side and right hand side, xy and xy get cancelled. We remain with x minus y minus 1, which is equal to 0. To solve this equation for x, we need to eliminate y. To eliminate this y, we have to use this equation. So let's solve this equation for x using this equation. Therefore, x minus y plus 1 is equal to 0. Using xy is equal to 56, we get the value of y, which is 56 upon x. Therefore, y is equal to 56 upon x, and the expression becomes x minus 56 upon x plus 1, which is equal to 0. By multiplying both sides with x, we get x square minus 56 plus x, which is equal to 0. And here we write in its order x square plus x minus 56 is equal to 0. Now look at the factors for negative 56. Negative 56 is equal to negative 7 times 8 or negative 8 times 7. If we add negative 8 to 7, we get negative 1, which is not equal to coefficient of x. So we don't consider this factor. We have negative 7 times 8. When we add negative 7 to 8, we get plus 1, which is equal to the coefficient of x. So we can rewrite this expression x square plus 8x minus 7x and 56 as it is. If we take x common from these, we get x times x plus 8. From these two terms, we will take negative 7. Then we have x plus 8. If we take the expression x plus 8 common, we have x plus 8, and we are left over with x minus 7. That is equal to x plus 8 times x minus 7 is equal to 0. By equating these two expressions, we get value of x. X plus 8 is equal to 0. or x minus 7 is equal to 0. The value of x is negative x or x is equal to 7. Here we assume x is the price of sugar per kg and there is no negative price. So we take the value of x is 7. Therefore, the price of sugar, that is the original price of sugar, is 7 rupees. This completes our solution. Let's move to the next question. In this question, we are given sum of n, 2n, 3n terms of an APR S1, S2, S3. We have to prove S3 is equal to 3 times of S2 minus S1. Let's work out the problem. According to the question, sum of n terms of an AP is S1. If we take A is the first term and D is the common difference, then the sum of n terms of an AP is n upon 2 times 2A plus n minus 1 times D. Similarly, sum of 2n terms of an AP is S2. To get the value of S2, in place of n, we substitute 2n so that we get sum of 2n terms, that is 2n upon 2 times 2a plus 2n minus 1 times d. It is because we have to find out sum of 2n terms. Similarly, sum of 3n terms of an AP is S3. S3 is obtained by placing n with 3n. That implies 3n upon 2 times 2a plus 3n minus 1 times d. It is because we have to find sum of 3n terms. To prove this relation, S3 is 3 times of S2 minus S1. We will take right hand side and we show that right hand side is equal to left hand side. To prove this, let us consider difference between S2 and S1, that is S2 minus S1. Let us substitute these values from the above results. We have S2 is 2n upon 2 times 2a plus 2n minus 1 times d, and S1 is n upon 2 times 2a plus n minus 1 times d. Let us simplify this. We take n upon 2 common from both these terms. Then we remain with 2 times this term. Let us simplify it. We have 2a, and then let us distribute this d inside the bracket. That implies 2nd minus d. Similarly, from this term we have taken n upon 2 common, so we remain with negative sign. We must be careful when we have negative sign. We write it as it is, and then we have this term, that is 2a plus n minus 1 times d. If we distribute n inside the bracket, then we have nd minus d. Let us simplify it. N upon 2 times, here we have 2, so we distribute 2 inside the bracket. It is 4 times a plus 4nd minus 2d. It is because we are multiplying whole expression with 2. And then we distribute negative sign inside the bracket. We have negative 2a, and minus of plus nd is minus nd. Similarly, minus of minus d is plus d. Let us simplify this expression. We have n upon 2 times. Inside the bracket, we have 4a minus 2a, which is equal to 2a. Similarly, we have 4nd minus nd. They are like terms. 4nd minus nd is 3 times nd. And then we have negative 2d and plus d, which is equal to minus d. Let us simplify it further. Then we have n upon 2 times. We have 2a, and then we have plus 3nd minus d. If we take d common, then we have 2a plus 3n minus 1 times d. What is this value? It is the difference between S2 minus S1. What we have to prove? We have to prove S3 is equal to 3 times of S2 minus S1. We already have S2 minus S1. If we multiply this equation with 3, we get 3 times of S2 minus S1, which implies 3n upon 2 times 2a plus 3n minus 1 times d. It is exactly equals to S3. What we have S3? S3 is 3n upon 2 times 2a plus 3n minus 1 times d, which is equal to S3. On rearranging, we get S3 is equal to 3 times of S2 minus S1. Hence, the given relation is proved. Let's move to the next question. In this question, two pillars of equal height are on either side of a road and the width of the road is 100 meters. The angles of elevation of the top of pillars are 60 degrees and 30 degrees. And it is observed from a point which is on the road in between the pillars. We have to find out the point between the pillars and the height of each pillar. Let's work out the problem. Let us draw a simple figure to represent the above question. Here BC and PQ be two pillars of equal height, which is h meters. Then the height of each pillar becomes BC, which is equal to PQ, and it is h meters. And we have given the width of the road is 100 meters. Therefore, the distance between pillar BC and pillar PQ is 100 meters. That means BP is equal to CQ, which is 100 meters. Now consider a point A in between two pillars, and we have given the angle of elevation of the top of the pillars from this point is 60 degrees and 30 degrees. Let angle CAB be 30 degrees and angle QAP be 60 degrees. And we assume the distance of the point A from the pillar BC be x meters. Therefore, PA becomes x meters. Then BA is x meters. Here we have total length is 100 meters. So the distance of the point A from pillar PQ is 100 minus x. Since the total distance is 100 and we have to find AP, we get it by subtracting BA from BP. That implies AP is 100 minus x. Here what we suppose is to find the height of each pillar and the distance of the point from each pillar. How we get this? Here we have two unknowns, h and x. To find these, we have two triangles, triangle CAB and triangle QAP, which are right angles. So by applying appropriate trigonometric ratios, we can find h and x. Now find it. Let us find it. Now consider triangle CAB. Here we have triangle CAB. We have perpendicular CB and base of triangle is AB. So which trigonometric ratio we have to consider? We have to consider tan or cot. So we consider tan, and tan of 30 degrees is the ratio of perpendicular to its base. Here BC is perpendicular and base is AB. Now substitute its values. Tan of 30 degrees is 1 upon root 3. From the figure we have BC is h meters and AB is x meters. By cross multiplication we get x is equal to h times root 3. Therefore we have got the value of unknown x in terms of another unknown h. To get the value of h, we consider triangle QAP. Here we have triangle QAP. QP is a perpendicular and AP is base. Here we consider tan. We have tan of angle 60 degrees is the ratio of perpendicular to its base. Perpendicular is QP and base is AP. Now substitute its values. Tan of 60 degrees is under root 3, QP is h meters and AP is 100 minus x meters. Now let us simplify it. By cross multiplication we have root 3 times 100 minus x, which is equal to h. Here we have two unknowns, x and h. We eliminate x. We already got the value of x, which is x is h times root 3. By substituting we get root 3 times 100 minus h root 3, which is equal to h, and we solve it for h. Let us distribute root 3 inside the bracket. We have root 3 times 100 is 100 times root 3, and h times root 3 times root 3 is h times 3, and on right hand side we have h. Let us distribute h times 3, which is 3h, to RHS. We have 100 times root 3, which is equal to h plus 3h. On rearranging we get 4h is equal to 100 times root 3. To get the value of h, we will divide both sides with the coefficient of h, which is 4. On dividing we get 25 times root 3. Therefore we have find the value of h, which is 25 times root 3. But we have given the value of root 3, so we substitute. Then we have 25 times root 3. Root 3 is 1.732. By multiplying we get the value of h approximately to 43.3 meters. Therefore the height of each pillar is 43.3 meters, and we have to find the value of x. So let us consider x is h times root 3. But we have got h is 25 times root 3. By substituting we get 25 times root 3 times root 3. Root 3 times root 3 is 3, and we have 25 times 3. Therefore we have x is 75 meters. What we have assumed h and x in the figure, we have h is height of each pillar and x is the distance of the point from pillar BC. Therefore we get the value of height of each pillar is 43.3 meters and the distance of the point from pillar BC is 75 meters. And this completes our solution. Let's move to the next question. In this question, two vertices of a parallelogram are 3, 2 and -1, 0, and we are given the point of intersection of diagonals is 2, -5, and we are asked to find the other two vertices, means the remaining vertices of a parallelogram. Let us assume this is be a parallelogram and it is a, and we name it ABCD. Let A and B be the two given vertices of a parallelogram. Our aim is to find the remaining vertices of a parallelogram. One of the way to find the solution is to use the property of a parallelogram. We recall a property in a parallelogram, that is, in any parallelogram, diagonals bisect each other. Here we have two diagonals AC and BD. Diagonals bisect each other means one diagonal divides the other diagonal into two equal parts. Here the diagonal AC divides BD into two equal parts. Similarly, the diagonal BD divides AC into two equal parts. Therefore, we can say that the point of intersection of these diagonals is the midpoint of each diagonal. Let it be a P. We are given the coordinates of point of intersection is 2, -5. Therefore, P is 2, -5. Since we know the two vertices A, B and midpoint P, we can find the remaining vertices D and C. How we find it? We find by using section formula. Here we have a special case of section formula. The midpoint of line joining two points with vertices A, x1, y1, B, x2, y2 is sum of x coordinate, which is x1 plus x2 upon 2 and half of sum of y coordinates, which is y1 plus y2 by 2. This is the midpoint of line joining A and B. By using this formula, we can find the remaining vertices. Here let us assume the coordinates of vertex DB, C, D and coordinates of vertex CB, A, B. Since P is a midpoint of diagonal AC, we have sum of x coordinates of A and C, which is A plus 3 divided by 2, and sum of y coordinates of A and C, which is B plus 2 divided by 2, is equal to midpoint, that is P, which is 2, -5. These two ordered pairs are equal when their respective x coordinates and y coordinates are equal. Let's equal their respective x coordinates. We have A plus 3 upon 2 is equal to 2 and B plus 2 upon 2, which is equal to -5. By simplifying this, we get the values of A and B, which are the coordinates of vertex C. We transpose 2 to right hand side, we have A plus 3 is equal to 4, and by transposing 3 to RHS, we have A is 4 minus 3, which is 1. Let's simplify this equation. We have B plus 2 upon -10, which is equal to -10 plus of minus 2, which is -12. Therefore, the coordinates of C are 1, -12. Similarly, we can find the coordinates of D. Therefore, we get the coordinates of C. Here P is also the midpoint of diagonal BD. Then the midpoint of diagonal BD is sum of x coordinates divided by 2, which is -1 plus C upon 2, sum of y coordinates divided by 2, which is D plus 0 divided by 2. It is equal to coordinates of P, which is 2, -5. Here we equal their respective coordinates. Here we have -1 plus C upon 2 is equal to 2. By equating y coordinates, we have D upon 2 is equal to -5. By transposing 2 to our right hand side, we have -1 plus C is equal to 4, and here we have -1. By transposing, we have C is 4 plus 1, which is 5. Similarly, the value of D is 2 times -5, which is -10. Therefore, the coordinates of vertex D are C, D, which is 5, -10. Therefore, C 1, -12 and D 5, -10 are the other two vertices of parallelogram. This completes our solution.
Let us move to the next question. In this question, we are asked to find the value of k if the roots of the quadratic equation kx times x minus 2 plus 6 are equal. The quadratic equation given is kx minus x minus 2 plus 6 equals to 0. We can further simplify this equation by distributing kx inside the brackets. So we get kx square minus 2kx plus 6 equals to 0. On comparing the above quadratic equation with ax square plus bx plus c equals to 0, we get a equal to k, b equal to -2k and c equals to 6. And in the question, he told that the roots of the quadratic equation are equal. So the discriminant d equals to 0. That implies b square minus 4ac is equal to 0. Let us substitute the above values in the b square minus 4ac equals to 0. We get minus 2k whole square minus 4 times a equals to k and c is 6 equals to 0. Therefore, we get 4k square minus 24k equals to 0. Let us take 4k as a common factor. We get 4k times k minus 6 equals to 0. That implies from this we can say that either 4k equals to 0 or k minus 6 equals to 0. That implies k equals to 0 or k equals to 6. But we know that the k should not be equals to 0. Therefore, k equals to 6.